Part 2, charging of capacitor. We'll do first a general study about the charging, how the process goes. So here, in this figure, we have a dry cell, resistor, and a capacitor, and we have a switch. Now for the switch, I can put it on the position 1, or I can put it on the position 2. If I put it on the position 1, this means I have a dry cell, a capacitor, and a resistor. And here we say that the capacitor is charging. So here we have the charging process of the capacitor. How does it go? So this is the positive and the negative of the dry cell, and here we have the capacitor, which is neutral. Now, since the capacitor is neutral, and here we have the positive part of the dry cell, so we'll have attraction of the electron from this plate, which is neutral. So the electron will be attracted, and then they will go through the dry cell to reach the second plate of the capacitor. So this plate, the plate A, will lose electron. It's losing electron. So it will become positively charged, while the second plate B is gaining these electrons, so to become negatively charged. Now, the direction of the current, it's from the positive part of dry cell to the negative part. It's opposite to the flow of electrons. So this is the current. When does this process end? So this process ends when U across the capacitor is equal to U across the dry cell. So if I have, this is P and this is N. So when I have UAB equals to UPN equals to E, then in this case, the process of charging will be completed. Why? Since we won't have any potential difference, any difference in the state between the dry cell and the capacitor, this means that the dry cell مش قادرة تسحب electrons from the plate of the capacitor. So if you want to write here at the beginning, this means at t equals to 0, what did we have? We have UC was neutral. So the capacitor was neutral. This means UC is equal to 0. While at the end of the charging, we'll have UC is equals to UPN, which is equal to maximum. This means E. This is UC maximum. At the end also, if I want to look at the current, there won't be any flow of electron anymore. This means there won't be any current, so I is equal to 0. بينما بالأول أول ما حطينا الكاباسيتور okay, so if you have the directly flow of electron, this means I was maximum, which is equal to I0. Now, this is equal to how much? So we can find it by using the law of addition of voltages in a circuit in series, which will give us UPN is equal to U of the resistor plus UC, and this is E equal to R times I plus UC. At t equals to 0, I have UC equal to 0. It was neutral. This means I will be equals to E over R, and this is what we call I0. If we have more than one, so this is equal to E over R. If we have more than one resistor, then it will be E over R total. And this is how we find the voltage and the current at the beginning and at the end of the charging process.